So the way we did derivatives in the past lesson, we're going to go through using power, product, quotient, chain rule on how to do derivatives of the previous questions. So you're going to learn today how to quickly do, if I give you y equals x cubed plus 3x squared plus 7x plus 1, you can do that in 2 seconds, the derivative of it. Rather than having to replace all of those with x plus h's, expand them, minus the f of x off, and then divide by h, and then replace a 0, you can do it in about 2 seconds. Okay? Using power rule. Today's lesson is the easiest lesson of the entire year. It might be even easier than grade 10. Oh no, this is, you'll see. This is easier. Okay, so the formula for power rule is if I give you d over dx of x to the n. Now what this means is if I find the derivative of x to the n, d over dx just represents the derivative. You're not going to do anything with the d over dx. It just means I'm finding the derivative of x to the n. What you do is you take the exponent, and this only works if it is a polynomial, okay? So if it's to a variable exponent, it's going to be a whole different ball game. You're going to end up with lns and stuff like that. But when your exponent is a number, we can do this, okay? So you take the n, you drop it in front, you rewrite it as x, and then you drop your exponent by 1, n minus 1. And that's how you get the derivative. You take the exponent, you drop it in front, and then you rewrite it as 1 less. So a quick example, d over dx just means find the derivative of, with respect to x, as x is being a variable. It just means find the derivative of, yeah. Okay, if I give you y equals 3x5 minus 2x to the 4 plus 2x to the 3 minus 3x squared plus 7. Imagine me giving this to you on the test and then saying, find y prime. Find y prime means the first derivative. Okay, so think about it. You would have had to have gone 3x plus h to the 5, expand that out, minus 2x plus h to the 4, expand that out, plus 2x plus h to the 3, expand that out, minus 3x plus h to the 2, expand that out, plus 7, then minus that all over h, cancel terms off, pull an h out, distribute into 0, get an answer, right? Fun times, I know. But with power rule, we can do this in just a second. So I'm finding the derivative of the y. The derivative of y is y prime. So I add a prime symbol to the y. Instead of y prime, there's 2 different notations you can use. There's Leibniz and other notations. So what you can do is instead of going y prime, you could write dy over dx. And that means y prime. So it depends on what prof you have, whether they like using the little prime symbols or whether they like using the d over dx symbols. Okay, so instead of writing y prime, I could write dy over dx and it would mean the same thing. Okay, so this is the same as if I wrote dy over dx. They're the same thing. Okay, now these are all polynomials, so they all have exponents that are numbers. So all I have to do is take the number, drop it in front, and then reduce my power by 1. When I take the number and drop it in front, of this previous example here, there was a 1 in front, but if there's a number in front, you just multiply them. Okay? So you can take the 5, drop it in front. I'm going to actually not skip the step for the first time, and then after this, you will probably skip the step and never do this long writing out again. But I'm going to show you. So you take the 5, you drop it in front, and then you have 3x to the 4. You drop the exponent by 1. Minus, drop the 4 in front, 2x to the 3, plus, drop the 3 in front, 2x squared, minus drop the 2 in front. 3x. What happens with a plus 7? What exponent is on a plus 7 on a constant? 0. It has a 1 on the 7 for sure, but if I write it with an x, it would be x to 0. So actually both of your answers are correct. If you just wrote it as a 7, it would be 7 to the 1. If you wrote it as an exponent, it would be 0. So this would be 7x to the 0, technically, right? So I'm going to prove why a constant just goes away. Well, how would it just go away? This would drop in front. So I get 0 times 7 x to the negative 1, because I would decrease it by 1. What's 0 times anything? 0. Constants go away. Constants, when you take the derivative of a constant, it goes away. So you could technically go plus 0 at the back, but there's no reason to do that. So it just goes away. And then we put them together. So we're going to get 15x to the 4 minus 8x cubed plus 6x squared minus 6x. Done. Yeah. Yeah. So I'm going to show you an example because the other way proved that this works. So if I give you this example, y equals 3x plus 1. And I'm going to show you using the old method that we get the same thing. Okay? So you can pay attention. You don't have to write it. Doesn't matter. So we're going to get the limit, the y prime, equals the limit as h approaches 0. And I'd fill in x plus h, right? So I'd get 3x plus h plus 1. So it would be 3x plus 3h plus 1. So I'm going to get 3x plus 3h plus 1 minus 3x plus 1 all over h. So I'm going to get the limit as h approaches 0. And this is a very simplistic one, right? I'm not making myself FOIL or anything. That one would have been way uglier. So I'm going to get 3x plus 3h plus 1 minus 3x minus 1 over h. 3x and the 3x cancels, the 1 cancel, the h and the h cancel, and I'm just left with 3. Do the derivative of it the way we just went over it. So it's y equals 3x plus 1. This x is to the 1, right? So what would you do? You take the 1, you drop it in front. So it would be 1 times 3, right? Which is 3. X to the what? 0. Now some people say, well, it has a 0, so it just cancels. No, what's x to 0? What's anything to the power of 0? 1. And this goes away, right? The constant goes away, and that's actually a 1. So y prime equals 3. So whenever you have anything as x to the 1, when you take the derivative of that, it's actually just the coefficient, just the number. So if I took the derivative of 9x, it would be 9. Because you would take the 1, you drop it in front, and then the x would become 0, right? It would go away. So constants go away, and derivatives of anything with a degree 1 just become that number, and the variable goes away. Okay? Now, when you take the derivative of a polynomial as well, the derivative is always 1 degree less. So if this is x to the 5, it's going to be x to the 4, right? When you do the derivative of it. Because it always drops by 1. So I told you if you take the derivative of a constant, it equals 0, right? And everyone's really good. If I say, what's the derivative of 7? You would tell me 0, or you'd sit there and be completely perplexed because you're like, what is going on? This is too easy. Sometimes when it's too easy, that throws you off. But most of the time, you'd be like, 7. Okay, it's 0. It goes away. What happens, though, if I ask you for this? Y equals e to the 5. Find y prime. So people will take the 5, they'll drop it in front, and they'll make it e to the 4 every single time. put e to the 5 in your calculator. So all this is e to the 5. So it's 2.71 blah, blah, blah to the 5. So it's just a number. It's like 2 or 7 or 1. It happens to be 1.48 decimal 4131591. So it's a constant. It's a constant. So when you take the derivative of it, what is it? Because it's just a constant. What? Brackets. So we will be doing questions, though, where it's like e to the x or e to the 2x or something like that. If your e is to a variable exponent, totally different ball game. It doesn't just become 0. You'd actually have to do the derivative of it, which we'll be doing with chain rule. But e to the 5 is just a number. It would just be like putting pi to the 5, right? Pi to the 5 would be 3.14159 blah, 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 to the exponent 5. F of x equals 3/4 x to the 8 plus 3. Find f prime of x. So this is a polynomial, just as a fraction coefficient, right? Still a polynomial. So f prime of x equals, take the 8, drop it in front, multiply it by the 3/4, x, drop this by 1, so it'll be 7. And what does plus 3 become? 0. So do I have to write it? No. Now this is 8 over 1, so we're going to do proper math. We're going to do 8 times 3, which is 24, divided by 4, which is actually 6x 7. Done. Example. So the only rule I've given you so far is that it has to be a polynomial. It has to be expanded. When you see this tomorrow, you'll think, hey, do product rule. But remember tomorrow when you say, hey, do product rule, that it's actually faster, instead of doing product rule, to just expand this out first, collect like terms, and find the derivative of it. Okay? So I can't do a polynomial. It has to be a polynomial. It has to be in like order, right? It's not right now. So I have to FOIL it out first and collect like terms, then find the derivative of it. So sometimes what people do is they'll FOIL it out and collect like terms, and they're like, there's the derivative, because they feel like they've done work. So that must be the answer, but you haven't actually found the derivative yet. You just expanded it out. Okay? So h of x equals 2x squared plus 3x minus 4x, and then minus 6. And we collect our like terms, so 2x squared minus x minus 6. And then we find the derivative. H prime of x equals, take your 2, drop it in front, and multiply it. So what will we get? 2 times 2, which is 4, x to the 1. Do I have to write the 1? No. Then this is negative 1x, so it's just going to become negative 1. Why? Because you take the 1, you times by the negative 1, which would be negative 1, and then you get x to the 0, which would? Yeah. And then what happens to the minus 6? Disappears. Done. If you have to do this the old way, you'd have to go x plus h in here, expand it out, distribute the 2, x plus h, distribute the negative 1, minus 6, minus that off, put it over h, solve it out. Right? So when you guys said, are you going to give me the formula? From now on, you're not going to want to see the formula, because if you see the formula, I'm forcing you to do it that way. Right? And not this way. Okay. What if I give you this? B of y equals c y to the negative 6. It's obviously not going to stay just that easy. So this actually isn't a polynomial. This is a rational. But if you can bring the exponent up and the exponent is not a variable, you can use power rule. Okay? No longer a polynomial because you have a minus 6. So that would move to the bottom and make it a rational. But you can always make a rational if there's only one monomial, one term on the bottom. You can always bring it up and do power rule with it. So, what? Yeah, but then you'd have to do quotient rule, which is way more work. So we'll want to keep it like this. So if ever you have a monomial, so one term on the bottom, always bring it up to a negative exponent and do power rule. So it's going to be b prime of y. You take your negative 6, you drop it in front. You multiply by the number c, or the constant of c. And then it's going to be y, and then this is where people mess up. When I subtract 1 off of negative 6, what does it become? Subtract 1 off of it. If I have negative $6 and I take away another dollar, I have this could also be rewritten as negative 6c over y to the positive 7, right? If it was a multiple choice, it could be in that form. Okay, what happens if I give you this? It gives you the derivative, which next unit we're going to use to be able to draw a graph. Remember, intervals of increase, decrease? I feel like I answer the same question every single time. It's the better way to find it, yeah. Quicker. Sure. Example. Y equals, obviously, every single derivative lesson, you guys are going to have to do fractions. So breathe them in, people. Okay. So y equals x to the 5/3 minus x to the 2/3. So what do? We take our exponent. Our exponent doesn't have a variable, and as long as our exponent doesn't have a variable, we can use power rule. We take our exponent, we drop it in front, we subtract 1 from it, rewrite our exponent. So y equals 5/3 x. When I subtract 1 from that, I'm just subtracting 3/3, right? You just need a common denominator. So what's 5/3 minus 3/3? 2/3. Minus, take my 2/3, drop it in front. X. I'm subtracting 1. So it's 2/3 minus 3/3, which is negative 1/3. So if they wanted to rewrite this, I'm fine with it being just like this. But if they wanted to rewrite it as positive exponents, which depends on who you have, you would have to write 5/3 x to the 2/3 minus 2/3 x to the 3rd on the bottom. Because the only thing with a negative exponent is the x, not the 2 that's in front of it. Now, they could also make you write that as a radical. So, let's say x to the 2/3, convert it to a radical. What do? This stays as the exponent. The top one stays as the exponent. The bottom one comes underneath and becomes the index. So this is actually equal to the cube root of x squared. So this could be rewritten as, 5 cube root of x squared over 3 minus 2/3 cube root of x. Like I said, I'm fine with it at this point, and I think most of the answer key is good with it to this point, but I just wanted to show you that it could go to that. Okay? Now, the answer key, and this should have a prime because it's first derivative. Okay, you try this one. Try that one out. This is h of t equals t to the quarter minus 4. And then I'm going to do h prime of t equals, take the quarter, drop it in front, rewrite the t, and then a quarter minus 4 over 4, because that's 1 over 1, or that's minusing 1, is negative 3/4, and then the 4 just goes away. That's that. You could write it as 1 over 4 t to the 3/4, or you could write it as 1 over 4 fourth root of t cubed. Any of those are fair. Okay, what happens if I give you this one? What's the great thing about this lesson is the only thing you've been taught is power rule. Therefore, you somehow have to get this into some way that you can choose power rule. Tomorrow you'll try and do product. So what is the square root of x? X to the half. Right? Now, we can't use power rule unless there's no brackets. Power rule only works if there's no brackets. So I have to distribute first. So this is x to the 1, right? So it's x to the half times x to the 1. What do I do when I have the same base and two exponents? You add them. So technically, you're going to have x to the half plus 1. Technically. And then you're going to have x to the half times negative 1, which is negative x to the half. What's a half plus 1? 3 over 2, because it'd be a half plus 2 over 2. So it's going to equal x to the 3 halves minus x to the half. Can you see how people are like, box this and move on? But you've not found the derivative yet at all. You've just expanded it out. Are you just so happy that you've done all this work? You box it and move on? Yeah. They're different radicals, so you can't. You can put together x's with the same exponents. So like 2x squared plus 3x squared is 5x squared. So if this is x to the half and x to the half, you can put them together, but because they're different exponents on them, you're done with putting, they can't make it any simpler. But now I have to do the derivative. So y prime equals, take the 3 halves, drop it in front, x, subtract 2 over 2. So 3 over 2 minus 2 over 2 is a half, minus, drop the half in front, x. A half minus 1 is a half minus 2 over 2, which is negative a half. And I'm good with it. Now sometimes, because these are both over 2, what they'll write is they'll write 3x to the half minus x to the negative half all over 2. They can do that as well, because they're both over 2. Okay, what happens if I give you this? Bless you. So this one I can't do power rule to unless you just have x plus or minus x plus or minus x, right? So what I first have to do for this one is I'm going to actually have to divide each term by x squared. So everyone's really good that if you're over the same base, you guys know you can put them together as one. So for example, if I gave you this, if I gave you x over 2 plus 3 over 2, you would tell me that's x plus 3 over 2 because they have the same base. And everyone's really good with putting them together and simplifying. People are really bad at remembering that you can expand them back out. So instead of writing x plus 3 over 2 like this, I could write x over 2 plus 3 over 2, right? I could write them both back over 2, correct? So same thing here. I can actually write both of these each over x squared. So I can write this as, what's the square root of x? X to the half. And I can write that over x squared plus x over x squared. So technically, I can expand them out. Everyone's really good at putting them together, but forgetting that they can actually write them each separately over that denominator as well. Now, what happens when I have same base, but division of exponents? Yeah. So we're going to get y equals x 1/2 minus 2. So I'm going to write it like this, 1/2 minus 2. I'm not going to skip steps so you make sense of it. And then we're going to have plus x to the 1 minus 2. So you have I'm just doing this one. Sorry, I know what you're saying. I was just doing this one beside. I'm going to do the math on the next step. So this would be 1/2 minus 4 over 2 is correct. So what's 1/2 minus 4 over 2? Negative 3 over 2. And then plus x to the negative 1, or plus x to the negative 1. Do you see how people would box this and move on? But you still haven't found the derivative. You've just put it into a form that you can now do the power rule with. So now I can do the power rule. So I'm going to get y prime equals, take the negative 3/2, drop it in front. X to the negative 3/2 minus 2 over 2, because we have to subtract 1 from it. So negative 3/2 minus 2 over 2 is what? Negative 5 over 2. Plus, negative 1 drops in front. Subtract 1 from negative 1, and what do you get? Subtract 1 from negative 1, what do you get? Negative 2. Now, instead of writing plus a minus here, I would rather that be just subtraction sign. So it's going to be negative 3 over 2, x to the negative 5/2 minus 1, if you want to write it, or just minus x to the negative 2. Okay. Your homework is page 181. Numbers 3 to 17 odd. Huh. 21 to 31 odd. And then at the beginning of class tomorrow, we're going to go over how we can find the slope of a tangent with this and the equation of a tangent with this. Because remember, the slope of the tangent is just the first derivative. So every single time we're doing this, what are we actually finding? Slope of the tangent. If I give you a point, you can plug it in and give me the actual slope. That's all we're doing every single time. So this is your homework. And then we're going to do